file here. Like this will always be a file, not a folder, right?
Yeah, yeah.
Or no?
You can assume in this case we're writing files. That's right. Um, keep in mind though that there can be yeah, keep in mind that like we're assuming these are writing files, but it might still be useful for you to distinguish between files and folders. So for your
Okay,
organization purposes. But yes, we're only writing files. That's correct.
okay, all right. And read and write. Okay, so probably start off by at least setting up the signature for the read and write methods, and can also get started on creating the object for the file system.
Okay.
Okay, so let me just erase this. All right, here, the main is fine.
Yeah, you can define your own subclasses as you need. That's that if you decide.
Yeah, okay. So public, um, public file. Just creating the private attributes. So we have a content, so string content
Okay.
and private string like I think location, right? Or like the directory of the or file name as well. So that's actually one thing. File name. Okay. So public file, creating the constructor now.
Okay. Yeah.
Name is equal to name. All right. Um, Now probably want to also pass in the directory, right? So all right. Now trying to I'm just thinking here like
Mm-hmm.
whether or not I should have a second class where I using and like instantiating the objects for like the file, um, maybe a class called system where we're instantiating or like, calling this object for this class, right? Or whether or not I should just do it all within this file class. Oh,
I mean,
right.
obviously you can do everything in one class, but I would say you should try to model the system, like as close as possible to what would be useful. So, for example, you can imagine someone instantiating some API of yours, right? Some file system API, and they're going to be able to interact with it in some way, right? So, I would say in that context, it makes more sense to have it in a separate class, and
Yeah, like
for
file system
yeah, like
class,
file
right?
system class, or honestly, you can just use the main class if it's just for handling the API functions. That's fine too.
Okay. Yeah. Um, Now I have a class for the file, but I'm thinking we should probably have a class for folder as well and subfolders, and then also the files that exist within the folder class, right? And probably I think maybe I should change the directory. Like I should remove this attribute because starting to second doubts about that. But
Okay.
I'll go ahead and create the file folder or design the folder class as well quickly. So,
Okay.
all right. So yeah, it's gonna have a name, and it's gonna also have subfolders, right? So probably use a map for that, which takes a string and folder object, because a folder can contain other folders within it, right?
Yep.
And then the files as well. So it takes in the file object that we created earlier. And I'm gonna probably maybe add some getters and setters for that if needed later on.
Okay.
So let me create the constructor folder. Um, hmm. I don't want to pass in like a folder by default because like yeah, when we create a folder, we're assuming the contents are empty, right? So I'll just
Okay.
define it as empty. Desktop files. Okay. And then we'll probably need a method to add folders, right? To like yeah, the subfolder. So
Yeah, that's for like these. If you're making helpers, those are for your purpose, right? Like
yeah, yeah.
keep in mind that the only
Oops.
API that you need to support externally is the read and write file
Yeah, and
for now.
like yeah, for now, like um I don't have to like create the endpoint signatures, right? Like I'm just assuming
No, you
that
can.
like I just need to design the backend methods for those, right?
Yeah, that's right. You can just these are essentially just methods that you need to implement on the API class. Yeah.
Okay. Forget name. Probably want to get that as well.
For the purpose of just this for time, we don't have to write getters or setters or
Okay.
anything. Yeah.
Okay. Okay. That's good then. Okay. So yeah, I don't even probably worry about the ones where we're just retrieving the simple attribute.
Yeah. Yeah. Yeah.
But okay. So yeah, we have one for add folder, and then I probably have one for um adding a file as well. So this isn't really a getter, so I'll probably implement this, but my bad. But yeah, rather than subfolders, I'll use the files map and just put it there. And assuming this getter is created already. So takes the name as a key and the file itself as the object
We can just honestly just make
or
all these things
cube like
public
that.
for now. So what we'll do is we'll just make these public. All
Yeah.
these fields public,
Okay, okay.
and you can refer to them directly.
Okay.
How's that? Yeah, do that.
Yeah. Okay, so file, okay, I'll just do file.name then,
Yeah,
okay.
just be name. Yeah, dot name.
Sounds good. Oops. Okay, so looking back, thinking about the directory, so we're actually getting passed in like our input to this problem is like a directory, right? Or no?
It's a full path, which contains a file at the end.
Okay. Okay, so let me actually work from there then. From like the file system when we're actually providing the path, and then we're splitting it based on, the folders and like the different parts of the directory. I
Yeah,
think that would help.
yeah, yeah. That's fine.
Yeah, I think working from a higher level would probably help. So, and that would happen separately in the file system. Oops. But yeah, so like you mentioned earlier, we'll have the root, and yeah, assuming the constructors, they're created by default, because we can just have like a default root set, where you like just have the default name of the folder as root,
Okay. The root folder
right?
doesn't really have a name in that sense. It's just that when a path
Yeah.
starts with the slash, that's the root that indicates
Oh,
you
okay.
start navigating from the root. Yeah.
Okay. Okay. Yeah. So read and write. So I'll create that. So the method signature I said, it should return a string for read file and takes the path and the file name. Or actually, we could just create the file object. So string path followed by string or file, the file. Yeah. Okay.
Read file should only take one string as an input, which is the full path.
Okay. It takes the path and then we.
And then
Okay.
return the contents of the file if it exists.
Okay. So I'm assuming once we have like a path, for example, right? As an example, it's
Yeah.
something like folder, like let's just say documents, followed by like file. We would probably want to get. I'm gonna create a method
Okay.
called get folder given the path, which would return the folder object, and I'll have that implementation within the folder class that I created. So just to keep that logic separated from the file system class, of course. So something like this, and then yeah, get folder, and actually let's do get file because that's what we want to read. Get file, and if file is null, we'll throw like throw an error.
Okay.
And
Yeah.
if it's
Yeah.
not null, then we can probably just we'll just read the file's contents, which should be a simple like getter.
Yeah. Okay. Yeah. That's fine. I'm happy with that.
Yeah. Okay. So yeah, like let's just do file dot read.
One thing I wanted to just point out first is that
Yeah.
your file variable is of type folder. Is that intentional?
Oh, oh, I think that was probably just a mistake on my part. It's meant to be file.
Okay.
Thanks for that.
No worries.
Yeah, and I can remove this so I don't need directory here. Okay. Okay. And then for folder, we have file, get file, okay, given the path. So in the file class, or string path, we're retrieving the file. I'm wondering if I should have this in the folder, like this get file method in the folder class or file class, or if it matters given the path.
It doesn't like really matter to be honest, but in terms of like functionality, I would say that the file class shouldn't know its own directory in the sense that the file class shouldn't care where it is. And for example, if you wanted to implement a traverse function, which is what this you can consider this to be, I would say put it into the structure where you need the traversal. So for example, in this case, if you're traversing through folders, then I would say that might make more sense through in the folder class. So like find file in the folder in the folder class, or get file as you put it. Yeah.
Okay. All right then. So I'll do folders dot get files then, probably.
Yeah, you can do like folder. For example, you can have like a function called folder.traverse or something, right? And then you pass in the path, and you can kind of use the path to decide which sub path to go down.
Okay. Uh, don't entirely. I'm not sure how I would implement that, but what I'm thinking right now is I would probably have a get folder to get like the last subfolder that we're in, right? And then once we have that, we can retrieve the file from um, that folder object because yeah, it contains the files. So
Sure. Yeah.
I
Sure.
probably
Yeah.
do something like this.
Yeah. I mean, it's flexible on where you put it. That it depends on. It basically the answer depends on what you intend to actually do in the function. To be honest. So
Yeah. Oh, okay, okay, okay. So yeah, you know what? I'll just probably do it all in the file.
you could just also you could also honestly just implement everything inside a read file. Or I would recommend a helper inside of. If you're gonna do it that way, I would recommend at least a helper inside the file system class. Um,
Okay.
but yeah, it's possible to also just write the implementation inside a file system. Yeah,
Inside the file
yeah,
system to yeah to get the file, right? Okay.
yeah. Like do remember that you have a reference to the root in this case. This is what you're defining, and so you can always go from there, right?
Yeah. Okay. So I would probably do something like get root and then split based on like the forward slash, right? And try getting like the last element like of that array and seeing if that folder exists, something like that. Or
It would be the first element, right? It would be the frontmost.
oh yeah, frontmost. Okay.
Yeah, yeah, yes.
Okay. I'll do that here. So I think you also mentioned getting I could have a getter for get folder. So let me actually do that. Getting the folder based on the path. I think I should just start with that. Sorry, what's that mean? Folder. Public folder. Get folder string path. So we want to split it by the forward slash,
Yeah, that works. That's fine.
and our current folder is the root, right?
Um, Not necessarily, right? This if you're implementing that inside of the folder class, you don't have a reference to the root.
Okay. All right. So, okay, what I'm going to do is I'm going to traverse through the this array and try getting like the um current or like the the subfolder, excluding like the last part because that's the file, right?
Sorry, say it again.
Well, so what I'm thinking of is like getting the last most folder, and that would be a subfolder. So I could just look into that directly. Like if we have right, we have like a directory or a path with 3 folders, right? And then like a file.
Okay.
Um, like what I could do is I could probably I think there's 2 ways. Like either like just in the first step, like getting the last most folder and then looking into its contents or its sub files and folders, or retrieving this folder and then
Mm.
getting
Okay. Like so, I think you're on the right track. One thing I'll be a bit more explicit about, perhaps, is so the first call to get folder. Well, in other words, like we're passing in the full path, right? And so
yeah
if you're let's be a bit more clear about this. If your structure, let's just say was this, right? So this is your string. Whoops. This is your string. So you have 1, 2, 3, right? So you have 3 directories and your file's 4, right? When we split this, right, we get 1, 2, 3, 4.
yeah
Right. So one thing you want to keep in mind though is right is 1 is going to be the first subdirectory. So in other words, the first call of this thing, right, uh, right, subfolders get 1 will one might exist depending if you put it in or not. We'll assume that these paths do exist, right? Right.
yeah
So right now the root has 1 as a subdirectory,
okay
right? And so you would need to obtain a reference to that 1 subdirectory before checking 2, right? If you were to check 2
okay
on this current iteration, on this current, instance, that's where this current instance of folder, you wouldn't exist.
oh okay I
So
see
you need to traverse the root of the folders.
yeah okay I get that. All right, so I mean if I understood that correctly, I would probably have a for loop and yeah, 1 second. So something like this where we're getting the subfolder or like yeah
Well, you have the subfolders, right? You don't need a method for that.
oh okay I can just call dot subfolder right then,
Yes.
and then dot get based on the key.
Mm-hmm. Right. And
Right. So I feel like that would get like we would be able to get 4 with this, right?
that would get you 3, but 4 is not a subfolder. It's a file. So
Okay, I see.
yeah, yeah.
Yes.
Okay, cool.
yeah, so there we have 3, and then I would do this being 3, I'd probably do current dot file to get 4, right?
Yes, that would be the right way. Yeah.
So okay, well, so this is the last most folder, so I'll just return that.
One thing you want to consider though is, in the event where a folder doesn't exist. Right. So
Like an example of that would be,
yeah. So if you
oh,
if
like
you
if there's just no folder in general, we just have a file
no, if
in the path.
the API user is requesting a file that doesn't exist, so they might be requesting a folder that doesn't exist.
Folder okay, so current could be null basically if we're getting a subfolder and this doesn't exist or is returned as null, right?
Yeah,
So just throw an exception then, right?
you could do that. Yeah.
Um, you get something like this?
I think
What am I
you
spelling
spelled it
this?
wrong.
Oh,
You spelled it right, but I think you spelled it right
uh,
below there. Or yeah, I think you spelled legal.
oh, the double A, my bad. Okay.
You're missing a G.
So we go.
Yeah, that's right. That yeah,
Okay,
it would be also be not a return.
throw. Yep. And there we're returning current. Okay. So in order to access that method, I should clear folder, or I could just put this in the file system.
You could, yeah.
Don't. Yeah. Let's put it in the file system. So I'm checking if we do have if the folder does contain a file in it. So if folder dot file dot get. So because we're um, looking in the map to retrieve like a specific file,
Mm-hmm.
right?
Yep.
I would probably need to pass in the key, which is I'm wondering would I have to split that here and get the last element, or like basically the value of 4 by splitting and getting that string.
Mm, depends how you handle it, but yeah, you would need to get the end of that string somehow.
Okay. Right, stop. -1. So I'm guessing like by doing this, I'm able to get the file name that we're after.
Yeah, that's fine. Yeah.
Yeah. Okay. Well, let me see how the map is defined for file. Let's here. Then folders, okay. So string, file, file string. Oh, okay, I need to add the rest of the condition. So now I can probably, yeah, okay, now I can probably get the file.
Mm-hmm.
Dot, yeah, file name. And yeah, we had this as well. If file is null, throwing that. Otherwise, we want to read. So I feel like this code needs to exist elsewhere, not here.
I mean, this is the opposite condition of this essentially, right?
Yeah. So I'm okay. This is fine as well then. Or yeah, else. So okay. Else file doesn't exist, right?
Yep. Oh, I think you might be
Then
missing a closing brace.
let me remove this. Print file dot read.
You're defining a file inside of the inner scope here, so it won't be visible in the outer scope.
Okay. All right. So I think that's good enough for like the read file. And
Yep.
now for write, we can do. I'm wondering. I'll probably define it here for now, same way. So public void write file. So going back to the definition, for write, it takes in the path and outputs void.
Mm-hmm.
And oh, so for write, are we like, do you want to add content into the file, like
Yeah.
pass in
Yeah.
a string
For now,
as well?
for the purpose of this thing, we can just we don't have to set the contents or anything. That's not the important part. So the API won't actually have the file contents, just the file path.
Just the file
Yeah.
path. So we're not manipulating the file at all.
Yeah, that's right. This is that's not the important part. Yeah.
Okay, so for writing, are we basically just checking if the file exists, or we're adding a file to the folder? Is that what's happening here?
Yeah, with blank
Like
contents.
I'm just having trouble.
Yeah,
Yeah.
yeah, that's
So
right. If it doesn't exist, you put the file there with blank contents.
okay, and if it already does exist, then we don't do
Yeah,
anything,
yeah,
right?
yeah, exactly, correct.
Okay. 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 So I guess first we would want to make sure that the path like is valid, that the folders mentioned in the path already exists, right? Because it can't write a file or create a file in a folder that doesn't already exist, right?
No, it can. It will
Like we
just
won't.
yeah, no, it
Okay.
can. It will just create the subdirectories recursively as needed.
Okay. Um. So just take a minute to think about how we can do this. I'll you take each folder mentioned in the path and just create folders and define its subfolders, like something like you got it, I think here. but the difference is that we're, instead of getting it, we're actually setting the subfolder, I think.
Yeah. You need to set subfolders. Well, you need to check if they exist so you don't overwrite them. If they exist.
Oh yeah.
Yeah.
Okay. Right file. So for int I. Okay. Or yeah, folder. I'm just thinking how we could go about this.
You always start writing from the root.
Okay, so we would need to check if like the root. Are we assuming that like the path entered, like they have a root that exists, or we also need to check for that as well?
No, the root always exists. So the first path of the path, the full path, is the subdirectory of root.
Okay. So directory path file name. Could you repeat that actually?
Yeah. So the first path in the first subdirectory in path is a subdirectory of root.
Okay.
Right. So this means that what did you call them? Get subfolders.
Yeah. Okay. All right. So we have the root, and here we're just checking get one root. Okay, and it's that. So and this root, is it like passed in the path, right?
It's passed in the file system. The file system has a reference to root.
File system has a reference to root. Okay. All right. So I'm looking at how I implemented read, we were traversing over and define subfolders.
Yeah.
So, but before I do that, I need to check if they exist first, right? So,
Yep. So you have all the parts in here, right? So
yeah,
parts will contain 1, 2, 3. Correct.
yeah,
So you want to create subdirectories 1 and 2 if they don't exist. And if
okay,
they do exist, you want to
so,
just traverse them, right?
okay. So I think that would be something like if parts I,
We can definitely start with the structure that's similar to the read traversal path you made, which is
yeah,
essentially where you have a current folder, and we can start with that at root as we know, because we always start iterating from root.
yeah, okay,
Yeah, why don't you just set that to root over here? Yeah. And then you want to check if the current subdirectories contain the current part.
okay. So current, if it contains a sub folder, right?
Yep.
So,
You can, but this needs to be iterative.
well, yeah. So I'm just defining a like subfolder class here, and if it's null, then I think that would mean
Okay, sure.
it's not. Yeah, then we would need to create one, I think. current dot. So we have the
You
map,
call
I
them
think,
subfolders,
for
right? Yeah,
subfolders.
subfolders.
Yeah, so current dot subfolders dot get.
Yep.
Okay, I won't
And then the
use this
current.
probably then.
And then you want the current part, right? So the part at the index.
Yeah, okay.
So this gives you the subfolder if it exists.
Okay, so if it doesn't exist, then we want to create it, right?
Yep. So if it doesn't exist, then you want to create it. Yeah, that's right.
Okay. So we could probably use this folder. We would want to add it to our current. So current dot subfolders dot put key and value. So parts I.
Mm-hmm. And what would the value be?
It would be the object. So like new folder,
Yep, exactly.
parts I being the name of the folder.
Mm-hmm. Yep.
Oh, okay.
Cool. And so, yep, that's right. Right. And so at this point, the subfolder exists. And so what do you need to do?
If it exists, then
Because you made it,
we
right?
can continue
Yeah,
traversing,
that's right.
right?
Yeah, continue traversing. So yeah, why don't you update the pointers?
Yeah. Since it's a for loop, it would continue traversing, right?
Yeah, but you need to update the current subfolder, maybe. Consider.
Yeah. Subfolder dot. We want to get its Oh wait, sorry. Current is equal to current dot subfolders, right?
Yeah, I think you need this part, right? To get the actual reference.
Yeah.
Cool.
Yeah.
And after you
So
traverse it,
yeah.
you'll still need to create the file.
Yeah. So okay, if we've made it to the end, which or like the last part, so like number 2,
Mm-hmm. Yep.
and we want to basically write this file into that current subfolder. So current dot files dot uh,
Yep. I think I need a -1 over here.
oh yeah. And just thinking how we would do this. Oh, it would be empty, right? So
Yeah, the contents will be empty, but the name would still need to be there.
yeah. Okay, so
Okay.
I think that does does the right function, but I'm just thinking if there's any other like edge cases to worry about. So here we're checking if it exists, and If it doesn't, we're creating it. And file. So yeah, we're also assuming that the last part is always the file, right?
Yeah, that's
And
right.
that it doesn't end like it's a valid input string, and that like it just
Yeah.
doesn't end in like a um folder. Or no, I mean, because yeah, we're assuming that the last part is a file. But if we're given like an empty string, I can probably add a case for that.
That's fine. We don't need to worry about
It,
the input edge
yeah,
cases. Okay.
okay, that's fine.
Um,
But I'd probably fix this though by like, I know that the write file and um read file shouldn't probably be in the file system maybe. Or I'm just thinking if it's like the right place to put it. And like specifically get folder, like this shouldn't be here. This should be in the folder class.
yeah, there's
But
definitely
I mean one way, yeah.
yeah there's
Like I mean if we could just talk about that, like how would you how do you use get folder within like these methods?
it just boils down to the implementations really. But
Yeah.
we have a couple minutes left. I want to ask a open follow up question before we get into some feedback. And this is going to be like a discussion, so you don't need to code anything. But say we want to now support a new API that returned the number of files in all subdirectories. So let's say
Okay.
this one doesn't. So let's say this you know this API this function doesn't take any input, so it's all files from root. What are some ideas you have
Okay.
for implementing this behavior?
Yeah. So because we have root defined in the file system, and like you said, we want to just look through all of
Mm-hmm.
the subfolders. So I'd probably do something similar to this. I would split it by a slash
Yep.
and um, have like this folder get folder, and I probably traverse through the path. So in the for loop, once I've got the first folder, I feel like I would have like another for loop there, and then traverse. Or actually, no, we don't need traverse because we're using a map. Once we've reached the first folder here,
Yep.
uh, thinking because then that would probably contain multiple folders as well, right? So it'd be something like folder dot get subfolders or dot subfolders, and then we would need to traverse through those as well, and then get the files. Like that's just one. I mean, I don't really
Yeah.
have a solution for
Yeah.
that,
That's fine. Okay.
but yeah,
Okay. Cool.
and then read the files. Yeah,
Uh,
like I know that's not like a great solution, but like I mean, if I could hear like the answer, like how would you do that?
yeah. We can go through that as well at the end.
Yeah, sure.
Okay. Let's cut into here. Uh, let's go through some feedback. But before we do that, I want to just ask, generally speaking, how do you feel about it? What were some things you felt worked stronger or weaker? And and after that, you can and then after that, I'll talk through some ideas I had.
Yeah, yeah, for sure. So, I mean, I've seen this question before, but I didn't quite remember like the solution of it or
Mm-hmm.
anything. I feel like I definitely could have, you know, had like a better thought process about
Okay.
it because, the solution didn't come to mind right away. I feel like I needed a lot of help.
Yeah.
Um, yeah, so
Okay.
and plus like then of course that hinders like communication as well. Like it's not really easy to go through like all of your ideas or what you're thinking when, you don't really have a clear solution in mind. So I think that just makes it harder. So personally, like I found it like just a bit challenging because at times I wasn't sure how to start, like you know just understanding the structure of like the path and how each parts can have its
Uh
own
huh.
folders. So I found that tricky to uh, understand,
Yeah.
um, which is why I think
Yeah.
it took a while to get to the implementation, and then therefore communication as well. Like I know there was times where I was just like sitting there trying like typing some code without really fully explaining it because I was trying to like kind of see how it would look
Yeah.
once written down and try understanding from there. So yeah.
Okay. Yeah, that's definitely kind of a theme, right? A lot of the I think a lot of this could have been potentially circumvented or prevented if you had worked top down from the start, right? So generally speaking, for OOD questions especially, it makes the most sense to start by like explicitly defining the how the API contract or whatever you're implementing looks like in code, right? So before you even do anything, as part of in fact as part of like the clarification phase of the problem statement, I would write out the signatures and return types, whatever it may be, for read and write file, right? And the reason
Yeah,
for
that
that is
too.
because that kind of anchors a conversation on things that really matter, and things that don't matter you won't come to talk to in the end, right? So for a question like this where it's relatively straightforward, that's less important, but it's still a good habit to get into because it's a time management technique, right? If you build stuff from the bottom up, it's oftentimes harder to know if you're behind schedule or ahead of schedule. So kind of start the other way around, right? Start top down, define the contracts, and then say, okay, what classes we need to support this, etc. Right? So that's kind of like a high level idea for that situation. Now,
Yeah, I noticed that as well. Like I went back, I tried looking it up from a higher level because I think I started kind of low level with it.
yeah. Now, for the actual class designs themselves, a couple things. This is so this pattern is known as the composite pattern. The composite pattern is when you have two classes, in this case, file and folder, and they kind of fit in the same bucket, right? So in other words, oftentimes you're treating files and folders the same way. For example, we didn't go through this edge case, so that's less important. It might be less obvious in this case, but an example for this is what would be the fact that a sub a sub item of a directory can be either another subdirectory or a folder. So in other
Yeah.
words, the distinction between file and folder is actually contrived and it doesn't really matter. And so had you
Okay.
realized that earlier on, you could have this would be called the composite pattern. You could have combined the two classes into one, and then you would have simpler logic for navigating this. But that's not a big deal. But some people would be looking for specific terminology. Hey, did you recognize that this is a pattern being kind of exposed here, etc. Regardless of that,
Yeah.
though, it doesn't. I mean, regardless of that, though, it should have still been fairly obvious that this is a recursive structure, right? So folders can refer to other folders, and vice versa. So generally speaking, the natural way to traverse this would be through recursion. And so that's why when I said it
Okay.
depends on, should the get file be put in the folder or whatnot, that's where it depends on, how you implement it. If you, for example, you're using references iteratively, then it matters less. If you're using, for example, recursive structures, it also doesn't matter that much, but then it would make more sense to put it as potentially a static helper in folder. That's kind of
Yeah.
distinction there. A couple of things I wanted
Yeah.
to touch on
Okay.
as well. So let's see, what did I mention? Yeah, so decision. So that touches on decision where to put the helper methods. There's one pattern I saw that you weren't potentially familiar with, which is you're checking if something exists in map. There is you can use the contains key method. So the map.contains
Oh
key
yeah.
returns true if and only if the key exists. That's something you could have done. And for example, if you're doing something where your get or put, like get if it doesn't exist, put, there is there's two things in Java. The easier one to remember is the get or default, which will return the default variable if it doesn't exist already. So for example, inside of here, you could have done something like subfolder, which by the way you didn't end up using subfolder as a variable, which should have been a hint that you didn't need it, but it's fine. So you can do
Yeah.
like that, someone current dot subfolders get or default, and then your key would be parts at I, and your default value would be new folder folder parts at I, for example. So this is going to be something which would have helped clean up the code a little bit. This isn't a big deal, by the way, but this is one of those things which shows that if you use Java a lot, you'll run into these helper methods, and so it's sort of like a cleanliness thing, right? It gives the interviewer a bit of confidence that you're familiar
Yeah.
with the language. So getter default, and
Yeah.
the
And
other
then like
and the other one is merge.
yeah.
Merge is a bit more
Yeah.
of a it's a bit more complex, but getter default is fine enough.
Yeah. And like you said over here, like I could have just used contains key.
Yeah, there's a couple of those. It's a bit nitpicky, but it does matter because it's a perception thing, right? What else?
Yeah.
This thing here caught my attention, which is that this should be started at root. Um, this is one of those things where it's technically wrong, but isn't that wrong because that's likely a typo or you misunderstood. But just keep in mind that if you are going to write something, like if you're gonna base your solution off of these kind of helpers, it's good to kind of just go through them and make sure that everything's sort of where you expect them to be, right? So some detail, attention to detail there.
Yeah.
And yeah, then so the last thing to kind of clean up, to kind of wrap the conversation is how the follow up kind of thing goes. This is one of those follow ups that gives you opportunity to kind of demonstrate demonstrate kind of like your understanding of the problem as well as any like insights you might have about it. Right. So yeah, the naive solution of just, for example, in this case, just starting at root, going through all the subdirectories and counting for each subdirectory, get the size of the files map, right, and add it up, right. So yeah, that is one way you can do it. There's a couple ways you can do it that might be a bit more efficient. The first way is to modify your folder class to also have a parent pointer. So for example, this case would be public folder parent, right? And so when you create this, you could have a, for example, folder parent ref this dot parent equals parent, right? And so this way you can traverse up and down, okay? And the reason you might want to do that is because if you were to add a file in here, you can have a count. So in this case, you would have so public file count. Well, so file count would equal, in this case, it would equal. Well, I'll put it this way, right? So, oops, this needs a type, right? This file count equals 0. When you add file, you can put it, so you can do file count plus plus, right? And then what you would do is you would traverse the parents. So in this case, for example, or no, you know what I'll do is I'll do this. Public void increment file count. Oops, I don't write Java very much. Okay. And then what you would do is you can have a function which is public void increment parent file count. Do you guys see what I'm getting at?
Yeah.
So then you would go through this dot parent dot increment file count, this dot parent dot increment parent file count, like so. And so
Yeah.
this
Got
way
it.
you would traverse up the tree, and in this tree structure, this will be on average log in. And so that way your root will always have a running count of the total number of files in the system.
Yep. Yeah, that's much better.
That I would
Like,
say would be
more efficient.
the quote unquote intended solution. But okay. Any other last minute questions before we call it here?
No. Yeah, you pretty much explained like how we would go about getting like the total files given, or like within the root.
Yep. Cool. Then yeah, thank you very much for your time. I will
Yeah.
catch you later. Take care.
Yeah, I appreciate it, Leo.
No
Thank
worries.
you.
No worries. Take care.
Take care.
All right. Let's go to the next person, who is May. Let me go ahead and.
Hello?
Hello. How's it going?
Good. How are you? Can you hear me?
I can hear you're a bit quiet, but I'll turn you up. Give me a second.
Okay. I can also turn the my volume up in the Discord.
Yeah, turn your volume up a bit if you can.
Okay, I got it to 90%.
I can turn you up a little bit.
Is that 75?
I can wait. Sorry, can you speak a bit again?
Testing.
Okay, I'll turn you up a little bit here, and you should be good. Cool.
Okay.
We're doing Leetcode today, yeah?
Yes.
Okay, cool. Let me get you in. Invite. Boom. All right. Let me know when you've joined.
Okay.
I think
Okay,
you're in.
I am in now.
Okay, sweet. Then let's get right into it. Is Python a preferred language? I can switch a language for you.
It's Java.
Java? Okay. Then there's a Java tab available, so you can just go there.
Oh, yes.
I did delete everything here, though. I think the class was called solution. Oh, no. Okay. Anyways, okay. Let's get into it then. Let me just make sure the stream's still good. And yeah, I think we're still good. Okay, let's get into it then. So let's get started into this Leetcode problem. Thanks for joining, everyone. Today's problem is going to be, we're going to do a medium Leetcode, and depending on how that goes, we might do a follow-up or a different question as a second question kind of thing. And so yeah, right now it's 3:06. We're going to try to end at 4, and with a 50-minute implementation time, that means we're going to be targeting 3:55 for your reference. Time management.
Okay.
Okay, so the first question is going to be about a island question. So essentially, we want to, so given a m by n 2D grid, okay, and this grid is going to be it's going to be a binary grid. Okay, so it's only going to be zeros or ones, numbers, or whatever type you prefer. We can just say zeros or ones, make it easy. Okay. And you're going to return a number representing the total number of islands. Okay, so an island is defined by contiguous portions of ones. Okay, and it's only considered contiguous if it's connected on the Cartesian coordinates, so north, east, southwest, up, down, left, right. Okay, so diagonal connections do not count.
Okay, got it. Yep. Is that it for the description, or?
Yep, that's it. Feel free to ask questions.
Okay. So yeah, I was just taking some notes as you were speaking, but just to clarify that I understand the problem, the input to the problem is an m by n 2D grid of binary values, either 0 or 1, with sorry, I think I didn't catch this part, but does 0 represent what does 0 and 1 represent again?
Yeah, so if you're doing the island analogy, 0 is water and 1 is land. But you're basically just trying to find the number of consecutive or contiguous groups of ones, essentially.
Okay, got it. So 0 equals water and 1 equals land. And we are supposed to return the number of islands in the grid. And the definition of an island is a group of cells that are connected via the Cartesian coordinates north, east, south, and west. Does not include diagonal connections.
That's right, yeah.
Okay, cool. Okay. Let me think about this. So we're after the number of islands.
Yep.
Okay, so just thinking out loud here, the first thing that comes to mind is we could iterate through the cells of this grid until we find a land cell. And at that point, we will try to find all land cells that are part of that island.
Okay.
And then once we do that, we increment the island count by 1. And then we continue on with our iteration. And then we just keep on, we do that for the entire grid, at which point we will have calculated the total number of islands, and then we will return that number. One thing that I think I need to consider is I don't want to be visiting land cells more than once, because that could lead to duplicate counts. So I'm thinking there needs to be a way of marking a island as having been visited.
Okay.
So that like we don't like revisit again, and that would like mess up the total count. So one solution to that is to mark use some kind of like marker character to indicate that that cell has been visited. For example, it could use like an asterisk. Um,
And where's this asterisk going to be stored?
it could be stored like in the original grid.
Okay. What if we can't modify
Yeah.
the grid? Let's put that restriction on.
Okay. So if we cannot modify the grid, it has to be. We have to keep the input as is. Then, yeah, one thing we could do is just like store the coordinates of the cells that have been visited, and then determining whether a cell has been visited is just as simple as just checking. I would guess it would be a set of coordinates, checking that set to see if this coordinate has been visited or not.
Okay. Yeah. Okay.
Does that sound reasonable?
Yeah, that makes sense.
Okay, cool. So I think that's the high-level idea of on how I want to implement this. Can I start implementing?
Yeah, that makes sense. Let's go for it.
Okay. Okay, so I'm calling this function it's running an integer num island. And this is taking I guess it could be a character array. Let's call this island. And we're returning I'll just write 0 for now. It's obviously going to change. Okay, so I mentioned earlier that we need a set of coordinates to keep track of cells that have already been visited. So this could be a no, I think there is a built-in type called pair, which works well here because a coordinate is literally just a pair of numbers, right? So
yeah, sure.
So this would be visited cells.
Okay.
It's going to be new hash set. Should I worry about imports or?
No, you don't have to. Java doesn't actually specifically have a pair, depending on what version of Java you use.
Oh yeah. I remember running into that. I remember running into that problem.
You should use generics here though. Yeah. For the hash set. Yeah.
Okay, and then there's gonna be like a running count of number of islands. So count, and it's gonna be start off at 0. Oh, and okay, so I'm just realizing now that one thing that I didn't go into detail about is how we're actually gonna like determine which cells make up a single island. So I think we could use like a recursive like depth first search method. And in that method, what we will be doing is given a cell, like we're going to be starting off on a cell that's bland, and then we're going to look at the four neighbors of that cell, and then counting the number of and then just like marking each of those neighbors, and also like neighbors of those neighbors, etc. As having been visited. So basically, if we're at a land cell, we need to recursively mark all the cells that are connected to this cell, or like add those cells to the visited set.
Yeah, that's right.
And it basically just you can use like any type of like recursive method for that. But the first thing we'll do here, after we set the count to 0, is iterate through the grid itself, checking each cell, checking for land. So okay, so the thing we'll be checking for is if this cell is land. So so this equals a 1, then that means we need to initialize our traversal here. I'm just going to call this method DFS for now, and I'll implement it as a helper method later.
Okay.
So this will take in the island. It'll take in the current coordinates. Yeah. And then after we're done with this traversal, we need to increment the counter by 1. The work of actually adding the visited cells to this set will be done in DFS, which means that we actually need to pass this. We could pass this into this function, or we can just like set it as a class level variable, but I think either is fine. I am just going to pass it in.
That's fine. Yeah.
Okay, so once we do that, we increment the count by 1, and then we continue this iteration until we're done with the entire island, at which point we return the count. Oh, not return count. Okay, so next thing we need to do is implement DFS. Okay, so this will be private void DFS, and then it takes in the island int. This will be the row, and then also take in a column, and then it will also take in the sets of pair of integer to integer. Okay, so depending on like how I want to implement this, I might need to do like some bounds checking right off the bat to make sure that the cell we're currently at is actually exists in the island.
Okay.
So if we do it that way, then yeah, that's the first thing we need to check. So if it's out of bounds, then we just return right away. So basically, if row is less than 0, or column is less than 0, or row is greater than or equal to island dot length, or column is greater than or equal to island index at 0 dot length.
Okay. Yep.
Then we return right away because we're off the grid.
Okay.
Okay, the other thing we need to check is if this current cell that we're at has already been visited. Then we just we stop the iteration. I mean the traversal right away.
Okay.
Actually, this could be like grouped into this giant if statement as well. So if visited cells dot contains, oh, I'm gonna have to create a new pair because I currently only have int and call.
Yeah.
Huh.
Do you know how to create a pair?
Yeah. So I think I could do that here to, because I'm gonna have to do it like later on anyways. I might as well do it like before this statement. So uh, if this contains the current coordinates, then we return. Okay, so next is we need to traverse the neighbors of. Actually, one thing I forgot here is we also need to check. We could check in this giant if statement if the current cell actually is like land or water, because if it is water, then we also need to stop the traversal as well. That's another thing we could check here. So if island row call, if it's equal to water, then we stop the traversal right away.
Okay.
Okay. Otherwise, we know that we are on a land cell that exists in the grid and also hasn't been visited. So in that case, what we need to do is we need to, first of all, add the current coordinates to the visited cells set.
Okay.
And then after that, we need to traverse the north, east, south, and west neighbors. So north would be row -1 call, and then, oh shit, I just realized I have to do a lot of typing here. I'm just gonna type the redundant variables first, and then add the
Sure.
changing ones. So it'll be, the redundant variables are gonna be like island, and then visited cells, and then I'm just gonna copy this 4 times before adding the other variables. So, oops. Okay, so north would be row -1 column.
I think your argument order is a bit off there.
Sorry?
The order of your parameters.
Oh, okay, right. I'll set this as the second parameter.
Yeah, I guess that works.
Okay, so that means I also need to do it here. Okay, and then for that's north, and then north south is row +1, and then column. East is row, and then column -1, and then west is row, and then column +1. Okay. Yeah, so once we visited, like we've done the traversal in all 4 directions, we have fully explored this island.
Okay.
So we'll be done with this island, and then we can just return it. We just return. All right, so it's the end of the function, so we don't need to explicitly write return.
Okay.
Um, okay, so I'm just gonna like run through everything again to like check if there's like any errors here. Or maybe one thing I could do is like I could like run through an example test case on the code that I've written.
Yeah, you can do that too. That makes sense.
Okay, so I'm just like come up with like a random a random island. Gosh, this might take a while to actually write.
You can use this one.
Oh, you have one. Okay, great. Okay, so this island should have. I mean, this bridge should have 1, 2, 3 islands, right?
Yep, 3.
Okay, so if we pass into this into num island, what will happen? So um,
You're a bit
okay,
quiet. Did you
first
did you
bridge.
did your mic move away?
No, I
Oh,
actually didn't change
okay.
anything.
No, you sound good now.
Is it better
You
now?
sound good now.
Okay. Okay, so the first cell is an island, so we'll start DFS right away. Um, so what will happen in DFS? Well, this is definitely in bounds and it has not been added to the set yet. So we'll just do DFS on starting from here. It will check in all 4 directions, but only the right and downwards directions are legitimate. So it will then go to does east come before west? So south comes before west. So it'll go to this cell, and then it will go to this cell, and then it will go to this cell. And I did remember to add visited cells to the set, right?
Yeah.
Yeah, right here, line 29. So that should be fine. So once this one is visited, these cells in this island would have already been added to the visited set. So once we go back to the main function, we'll be at the second cell in the first row, but this will have already been visited, so we don't call DFS here. And like
Sorry, can you say
so
that
on
again?
and so forth. Yeah, so since the cells of the island in the top left corner have already been added to the visited cells set,
Yeah.
they will not be visited again in the main function.
Can you describe why that
Mm,
is?
Um, oh, sorry. I think I misspoke there. Like DFS will still be called, but it'll just return right away because visited cells already contains all the cells in this first top left island here.
Yeah, I agree. And what happens to the
Yeah,
count in
yeah.
that case?
What happens? Oh shit, that's actually a good point because it will be incremented again, even though it shouldn't be.
That's right.
So I think what should happen here is we should actually do a check here right away to make sure the cell hasn't been visited to prevent that.
Yeah, that makes more sense.
Dang. Whoops. Okay. So this visited does not contain. Oh, I guess we have to make a new pair here. And waste a little bit of memory. Shit. No, IJ. It'll be. Only if the visited set does not contain the current coordinate, then we do DFS.
Is that meant to
Yeah.
be or?
So I totally brain farted. There should be an and.
Okay. Okay.
I think that
Okay.
should be correct now.
Okay. Yeah, looks good to me as well. Let's go to the time and space complexity for your implementation.
Right. Okay. So in terms of time complexity, so in the outer function or like the main function num islands, we're visiting in each cell once.
Mm-hmm.
And then in DFS, okay, I want to say I want to make a statement here. I'm not 100% sure if it's correct, but each cell will be visited. It will be visited at most um, at most 4 times, because say we could have like a cell, say it's the cell that I'm highlighting here
Sure. Yeah.
in it'll be visited, like it could be visited from the left, right, top, or bottom, but once it's visited from the left, like it's not possible to visit it from the left again, because that cell will already have been added to the visited cells set. So because each cell will be visited a constant number of times, the overall time complexity would be it'll be the size of the island, which is m by n.
Okay.
And then in terms of space complexity, the thing that we're storing that depends on m and n is well, actually, I don't know if it depends on m and n, but visited cells is the auxiliary data structure that we're storing, and that depends on the number of cells that are land, which I guess could be, at worst, it could be all the cells could be land, in which case we'd be storing m by n.
Okay.
Another thing to consider is DFS, which is a recursive function,
Mm-hmm.
and so the space complexity of that depends on the depth of the call stack. So let me think about that. What could the maximum depth of this call stack be? In worst case, I think it could also be m by n.
Can you explain why
Like
n
it
by
could
n?
be, yeah, if we have like um, if our grid is like if it's like one by something or something by one,
Mm-hmm.
then in that case, there's a possibility that we need to visit like every single cell while traversing the current island.
Is that the connection there's not clear? Why is it that needing to traverse every cell, which I agree with? Why does that necessarily mean that the call stack will also be n by n? That implication is not clear.
No, I'm just coming up with like a case where that would be the case. Like if we have like a skinny
Yeah.
like a skinny island, right? Where it's like one by like some number, which is like greater than one or something.
Is that generally
Like
true even if it's
in
not
that
one?
case. Sorry?
Is that generally true even if it's not one by n but m by n?
I'm okay. I wanna think about this for a bit before saying yes or no. Okay, so so this function first prioritizes visiting the northern cell, the cell to its the cell that is above it, before going to any other cell. So in the worst case, just looking at this, the first call to DFS, at worst it'll traverse the length of the entire column, which is m, before moving on to the next one. So the second call to DFS, it will traverse the entire all the cells to the south or bottom. And in the worst case, that would also be the entire column. Similar sort of thing for the next two calls, except it would be traversing the entire row. I'm just trying to think like what that does to the overall time complexity of, the overall space complexity of DFS.
It's a tricky question.
Yeah, I know. Oh gosh. Okay, so this the second call on line 31 to DFS will not happen until the first call is like exhausted.
Do you mean these two calls? Because there's two calls.
Like the first call to DFS will continually be called until it's not possible, until like we're out of bounds basically.
Until
it's not possible to call DFS anymore.
Yeah.
At which point we will start calling the second call to DFS. So in the worst case, there will be m calls to the first DFS before we start calling the second DFS. Same thing here. Like at worst, there will be like m calls to the second DFS before we start calling the third DFS. And then at worst, there will be n calls to the third DFS before we start calling the fourth DFS. Okay, but what does that say about the overall complexity? There could also be a case where like we make one call to the first DFS and then like a call to the second DFS. Like it's not guaranteed that we'll only be calling the first DFS until we can't anymore.
But it is.
But the overall, right? Like the overall like call stack doesn't end until like we visit the entire island.
Yeah.
I'm just thinking like in the case where like the entire island is filled with land.
Yeah.
Like what would a call stack look like? I think the call stack would be of size m times n. In that case. That's my intuition, but I'm just trying to explain why.
Okay, we can revisit that. We can revisit that. This is gonna take too long
okay.
At this point.
Okay.
We have about 10-15 minutes, so why don't we? So I'll ask a follow-up question about this problem.
Okay.
And a follow-up question adds a bit of complexity. Okay, so first of all, let's assume that the implementation currently is correct. Now I'm going to introduce a second grid. Okay, so a second grid. So the first grid, you can call it grid 1, or islands, whatever you want to call it. The second grid is also similarly, it's the same. It's another grid of islands. Okay, so it's another m by n grid. And it's the same dimensions, by the way. So it's the same m by n grid, 2D grid, binary values 0 and 1. Okay, and so the second grid also has some number of islands. Okay, now in this new function we want to return, In this new function, we want to return the number of islands in the second grid that are wholly contained by an island in the first grid.
Oh, okay. Okay, so we want to just to like just to reiterate what you said.
Yeah.
We want to find the number of islands in the first grid that are wholly contained by an island in the second grid.
Other way around. But yeah.
Other way around.
Yeah.
Okay, so we want to find the number of islands in the second grid
Yes.
that are wholly contained by an island in the first grid.
That's right. Yeah.
Got it.
In other words, we want the number of islands in the second grid, or the number of wholly contained islands in the second grid, and we'll define an island as wholly contained in this case if every land coordinate of that island in the second grid is also land in the first grid.
Okay. 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 I think I understand the problem. For example, if like this is an extreme example, but if the first island was like all land.
Yep.
And then the second island was the island shown in the example here.
Yep.
The answer would be 3, right?
That's right. It would be 3. Yeah.
Okay, but if the first island contained only let's just say all ones in the third row.
Okay.
And the second island was is a given island in main, then the answer would be 1, right?
So I didn't follow the second example. So in the second example, you say so this is grid 1.
This is grid 2.
This is grid 2.
This is grid 2.
Okay, and then
yeah.
And what was
so
grid 1?
If grid 1 was just the third row filled with ones,
and all else was zeros.
All else was zeros.
Yeah, then it would just be 1 because it would only be this island that's totally contained.
Okay, I think I got it. Okay. Okay, interesting. Just thinking off the top of my head, one thing that we could do is just keep track of the islands that are in the first grid. What I mean by keep track of is like for each island, list like have a set of the number of cells that are contained in that island.
Number of cells.
So of the cells themselves, maybe like using a set or some other like collection.
Okay.
So that would be for each island, and then there'll be like some like way of some algorithm to do that, and then once we have that, we will look at the second grid, and then do like the same process, like find all the islands in the second grid, and then what we'll do is like for each island in the second grid, we will like somehow check each island in the first grid to see if it's contained in that island, doing like some kind of modified like set comparison.
Okay.
And then from there, we should get an answer.
Do we actually need to count the islands in the first grid?
Do we need to count the islands? Oh no, I don't think I'm not counting the islands in the first grid. I'm just like storing the cells of each island in the first grid. I'm not like counting.
Okay, I see what you mean. How is that different? Like if you were to store, for example, you're saying store all these cells of a given island in grid 1. How's that different from just the grid itself, which tells you if a coordinate is land or water? Like what do you benefit from knowing the coordinates of a specific island?
Oh, right, I see what you mean. So I believe, like, if I'm not mistaken, one of the requirements of the question was that we need a cell in. I mean, we need an island in the second grid to be wholly contained by an island in the first grid. Um,
That's true. It
so what does that imply?
well, what I'm implying here is that knowing that all the islands, knowing what cells an island contains in grid one is not actually necessary because the counterexample you're trying to think of is what if it's contained by two islands in grid one, right? That's not possible because then that means that the two islands do not wholly cover the grid two island because otherwise it'd be one island in grid one.
Yeah, yeah. Yeah, that's true. So if we don't need to like keep track of like the islands in grid one, one thing we could do is just basically for each island that we find in grid two,
Yep.
just basically check just check if like all those cells are ones in grid one.
Yeah.
And, is that all we need to do though? Because there's a requirement that we like the cells cannot be diagonally connected. But if an island, if we find an island in grid two, the definition of island is that cannot be diagonally connected. So
Yeah. Yes. Yes.
yeah, we can just do that. We just basically find all the islands in grid two, and then for each island, check if the cells of that island and island one are all ones. And if it is, then we know that the island in grid two is wholly contained by island in grid one. Yeah.
Yeah.
I think that's what I would do if I I know we're running out of time, but
Yeah.
if I had time to implement, that's what I would implement.
Yeah. Okay. That sounds good. Yeah, we're bad at time, so we won't be implementing that. And let's just call it here, and let's go through some feedback for it because I think there's some to talk about in terms of the time and space complexity there.
Yeah.
Cool. Then yeah, let's just start off with how you felt with your solution.
Yeah, so I think I had a good intuition of like how to go about solving this problem.
Okay.
The main challenge was actually just like the implementation details of this problem. I had like the main idea like pretty quickly, but like I think I remember like I forgot that I needed to like check the visited cells array. I mean the visited cells set.
Yeah.
First before like diving into the traversal, which something an oversight on my part, which would have resulted in incorrect solution. I think other than that, I felt pretty good about the implementation part.
Okay.
I think that I had a hard time like justifying the space complexity of the function though.
Yeah, we can talk about that.
I have an intuition that it is m by n, but I wasn't able to like explain it well.
Yeah. Yeah, it's not easy to explain. Okay. Yeah. Let's.
Like, I
Let's.
think time complexity I was able to explain, but then space complexity I had like a much more difficult.
Yeah, I know for sure. Yeah. Okay. Yeah. Let's talk about that. So the first thing, let's start from the top, right? There was some good stuff in terms of, you had a pretty, I agree, you had a good intuition about how to solve these kind of problems. One thing I will say just off the bat though is that, like, there can definitely be, like, you spent a good amount of time at the start with the clarification, right, with forming an idea, right, and then kind of getting alignment there. If you're gonna if you think that you're gonna be spending time to make a follow-up example anyways, or not a follow-up, an example input to test, this is where you should have done it.
Oh, okay, I see what you mean.
So
because I think I ended up doing it like after I
exactly
things.
Right. So basically, when you made the example at the end, you reaped none of the benefit of having that example to look at when you're coding it.
No, that is a good point. Yes.
Okay, so yeah. So that's the first thing. Otherwise, like in this case, I think he actually got the problem pretty well, so I don't think that's too big of an issue. But this is something which you could definitely like. This thing you could definitely kind of work on in the future because again, there might be a problem that you don't have that intuition about, and then yeah, it will definitely help you if you know if it ends up going that far, right? Um,
Mm-hmm.
okay, so yeah, so that's the first thing. One thing I will also say is uh, the setup was pretty good and you had high clarity before kind of proceeding, and I think that's kind of why you were able to finish it pretty quickly. So by like 20 minutes 25 minutes into the implementation, you basically got down all the details. Again, right, there were some small things you missed that affected the correctness, right? So the check I mentioned
Yeah.
before, um, in terms of preventing that stuff, because it seemed like a lot of this problem, the bulk of it was in the DFS, right? That doesn't mean
Yeah.
you still got to keep in mind that like the correctness of everything around it is still really important, right? And so
Yeah.
one thing you can write to yourself to kind of remind yourself, and you can to also kind of tell the interviewer your intention for the future, is to state out the invariance, right? So for example, the count here will only be incremented once we visit a new island,
Oh, right, right. A
right?
new island.
Right?
Keyword.
So one way you can, for example, one way you can be, depending on the difficulty for this problem, I don't think it's necessary, but depending on the difficulty of the problem, you could go as far as to say, like, for example, for this piece of code, right? You could say, um, if if next chord is new, ij, like you could do this, right? And then that way you're forced to implement this helper function the way that you originally intended, right? So for example, if you had implemented this originally without considering the visited cells, right? Now when you come
Mm-hmm.
back to it and you need to implement the next coordinate is new, it would make sense. Oh yeah, right. I also need to now check the visited cells because otherwise it wouldn't make sense otherwise.
Mm-hmm.
Right. So this is one way you can be a bit more explicit about it. I think generally speaking, the problem of this difficulty is just because you forgot. And so it's up to you to
Yeah, yeah,
determine, did you forget, and it's a systematic thing. If it's systematic, then you should force yourself to be more correct by writing helpers like this,
yeah.
right? But if you think it just slipped your mind, and I hope hopefully that is the case, then yeah, just be more careful about that, right? But this is a
I
system
think
you can use
there's a
to kind of safeguard
yeah.
yourself.
That is a bad habit of mine of like where I blame Leetcode shifting responsibility to the platform where I if this was like Leetcode, I would just rely on the submit button or something to catch this error. But I think that's a bad habit because uh, the submit button is not always there. It's never there in interviews. So
Yeah, yeah, it's
I then
important.
just like resist the temptation to like press the submit button and instead just like look at my like review the code again, um, as if it was like a code review and like a as if it was like a code review
Yeah,
rather than just relying on the submit button to be my code reviewer.
yeah, I agree. Right, it's important also because, and it's not only that you have to review it and catch a mistake. It's also, I'd say, relatively important to get it right the first time around because when you first wrote that line of code, you had already decided on the implementation idea, right? It's not because you added visited cells later that it was incorrect. No, you always had it, and it was never correct, right? That's an important
Yeah,
distinction because if, for example, this was the second question of the interview and there was no time to go through the details afterwards, this would just be marked straight up wrong because you have misunderstood the purpose of doing DFS, right? So
yeah,
it's
yeah.
important. So this is right. So writing the helpers is another way to kind of safeguard your intention, but just keep that in mind.
Mm-hmm.
Okay, what else? Let's see. So DFS implementation was pretty good. One is that when you said this, you said it backwards. You said column -1 was east, and you said column +1 is west. That's technically backwards,
Oh,
but
right,
it's not a
yeah.
big deal. It's still correct. Okay, now let's talk about the time complexity. Right. So time complexity. This is pretty trivial. This is indeed n by n. That's not very because you have to traverse everything at least once. Um, and I think one thing which and okay, the space complexity. This is the part which I think is a bit more tricky in the sense because the way that you wrote the DFS did not help you visualize the situation. And what I mean by that is that you are checking you are checking reactively instead of opportunistically, right? So even if row -1 becomes invalid, you still add this to the call stack. Okay,
Yeah.
and so that makes thinking a bit harder. However, the way I would recommend you think about this kind of size is if you're checking like reactively, just imagine that your grid is n+1 by n+1, right? Then it's identical. Um, the the difference there really is, like, for example, if you're checking opportunistically instead, you would only like queue this onto your call stack if row -1 call is valid. Okay, so that's like the other way around to do it. Now this is more clean code, so that's why I know why people prefer this method, but this is just a distinction you should keep in mind because that might help you think about things. Okay, so how do we count the recursive maximum depth of DFS? Right. So for example, you were right. So let's say we're just in some like, let's just say for the sake of argument we're in the middle of the grid, right? And there's no visited cells, just so we can go through the iteration, right? So if you're in that case, that means you will be going row -1, so north, right? You'll be going north continuously until you hit the edge.
Are we assuming the island is like all land?
Yeah, I assume it's all land right now, just for like maximum complexity, right?
Okay.
So you would go north until you hit the edge.
Yep.
Right. The question here is, at this point, how big is your call stack? And the call stack size here, do you have intuition for that?
Yeah. So it could be up to number of rows.
Correct. Right. It could be so.
Which is m.
Yeah. Right. Exactly. So the maximum call stack, if you were only to go up and down, obviously it's not realistic, but if you only had these two calls, right, is let's just call it m. M is the number of rows, right?
Yeah.
That makes sense. And the reason that's m and not like m by n or something else is because you only on queue a constant number of left and right columns. So you're not expanding the left and right columns. You're just on queuing a fixed number of them. Right? And what's the opposite condition? The opposite condition is if you're going just rows. If you're going in a row, you're going left and right. Okay, like if you're going left and right, then what's your maximum complexity for time? For space?
For space, the depth of the recursion stack would be limited by number of columns, so which is n, and then you'd be making a constant number of calls to north and south. So and it would end up being just O of n.
Yeah, it'll be O of n. And so what that means essentially is, but like, okay, right. So that's the idealized case, right? Essentially this is like the 1D case you were talking about before, right?
Yeah.
I think the detail here is if you are increasing the, and this is the base case, right? So the base case, right, is basically the maximum of m or n for a low dimensional, what the hell do you call it? For a low dimensional matrix. That's what it's called.
Yeah.
All right. And so when you grow the dimension, the assumption that breaks is that you on-queue a fixed number of the other dimension, of the other direction, right? Because now, every time you on-queue one of these other directions, that's going to get popped off the stack eventually, and then you'll have to go through all of those as well.
Yeah.
And so I think that is a bridge of intuition that gives you the eventual time complexity of n by n. Because if you can't assume that you can always add a fixed number, if you're going vertically, a fixed number of horizontal dimensions, then that's the part which, instead of becoming plus a fixed number, becomes times a number. And so another way you can think about it, for example, that I'm imagining, but I don't know if it's exactly correct, but this way I'm imagining it as well, is if you have a diagonal, right? So if you have a diagonal structure, then you would alternate the top of the stack being either a row traversal or a column traversal.
Do you mean if like the island was a diagonal?
Yeah, the island was like up down, was like the 0, 0, 0, 1, 1, 0, 2, 1, etc. So it was like a staircase, right?
Okay.
Like we can think of a staircase with some like thickness, for example, right? In that case, when you iterate through, when you iterate through the that staircase, sometimes you'll be iterating through the row part, and sometimes you iterate through the column part, right? And so there's no so that way that breaks the assumption that, for example, you can go through all the vertical and all the horizontal ones first or second, right? And so that dimension, right? That dimension is bounded by n by n.
Yeah, I think like to convince myself of the spaceliness, what I'll do after this is just like literally just go through, just like brute force an example of like the island being all land, and then just seeing like experimentally like
Sure, you can
that the call stack is actually
you can do
n by
that.
n.
Come
Sick.
come report back.
Yeah.
Oh, cool. Yeah. Anything else? Oh, we can quickly talk about the follow up. The follow up one, no.
What I ended up saying, I ended up like not needing, like I ended up like saying something that I didn't need, which is like keeping track of the number of islands in grid 1. Like I'm just wondering, like why did I say that? Why did I say that?
Well, you probably
I
said
don't
that.
really think too much of it. I was just thinking off the top of my head.
Sure, sure. I mean, it still would have been. The thing is, like with that solution, it still would have, with what you said, it still would have been correct. It just wouldn't have been necessary, right? In other words, you would have run this island algorithm on both grids 1 and 2 when you only needed to run it on 2, which
Yeah.
has still the same complexity, technically speaking, but is going to be twice as slow, right? So, so there is a bit of a difference there that you have to be aware of.
Oh yeah.
Yeah. Otherwise, I think you got the idea fine. It's just that, yeah, the initial ideation was, I don't think you got fully like clear, but your proposal was fine. At the end, yeah. Okay. Any other questions about that?
No, I think a lot of good ground was covered, and nice to do another rep of these mock interviews again.
Yeah, for
I
sure.
think I've done like 4 now.
You've done a couple, mostly. Yeah, you've done 2 the system design ones, right?
Yeah, I did like two system design, and then 1 OOD, and then 1 Leetcode.
Yeah. Okay, cool. Then I'll catch you next time.
Yeah, thank you very much, Leo.
Take care.
See ya.
All right, now let's see. Where is this? Okay, now let's get the next person in. Where are they? There they are. Here they are. Go ahead and send this person the notes. Like so.
Hello.
Oh, hello. How's it going?
Not bad, yourself?
I'm doing pretty good.
Nice. How's your vacation?
It was pretty chill.
Nice.
Let me get you the link here. Go ahead and join up.
Yeah.
Okay, let's see. Where the hell are we doing? Where am I? Where am I? Okay, cool. All right, are you in? Looks like you are.
Yeah.
And are we gonna go C++?
Yes.
Okay. Oh,
probably.
I see. You already made it. Okay, cool. Cool.
Yeah.
Sounds good. So, what are we doing? We are doing. Let me just check my notes here. We're doing a medium Leetcode. Is that right?
Mhm.
Yeah, medium Leetcode. Okay. And sorry, hold on. Where's my form? I'm trying to find my form. Where's my form? I'm trying to figure out what the focus is today. So let me just pull that up.
Oh, I see.
Execution. Okay.
I can't remember what I put it on.
You put execution.
Either.
Is that still going to focus on?
I see. Yes. What are the different options again?
Execution, collaboration, communication, and like problem solving, identification.
Oh, I see. Yeah. Execution sounds about right.
Okay.
Yeah.
Then let's just get right into it then. Again, right?
Yeah,
So
for
this is
sure,
going to
for
be
sure.
with medium levels. It's 4:05 right now. We have until 5. For a 50-minute
Mm-hmm.
target solve, we'll go to probably about 450, 455 if we have to push it. And
That's good.
because it's execution focused, I'm going to see how many problems we can kind of get through in this front. In this case, we're going
Mm-hmm.
we're going to go through, depending on like the question, depending on the speed we go through them. We might go through a follow up on the same question, or we go to a different question.
Mm-hmm. Sounds good.
Okay, so let's get into the first question then. So in the first question, I
Mm-hmm.
want you to write me a function called compress. Okay, it's going to take in a
Mm-hmm.
string. And you
Mm-hmm.
can choose for the string to be a literal string or it can be a array of characters. That's up to you to decide. Okay,
Mm-hmm.
and the string is always. Oh, sorry, I got disconnected. Oh, I'm good. Wait, oh, I'm good now. Okay, sorry.
Mm-hmm.
The string is going to be lowercase English.
Mm-hmm.
Okay, and you are going to compress the string. And here is the
Sounds
algorithm for
good.
you to use. Okay,
Mm-hmm.
you're going to find consecutive characters that are the same character. Okay, if this group of consecutive characters is length 1, you just append
Mm-hmm.
that one character to the output. Okay, else,
Right.
otherwise that means a group is at
Mm-hmm.
least 2 or more in length
Mm-hmm.
of the same character. Then you append
Mm-hmm.
that one character followed by the length of that group as a number.
Mm. I see. I see. Okay. Mm-hmm. And is that all?
Yeah, that is all. And then you can return, and then you can return the length of the encoded string.
I see.
Yep.
I see. I'm just writing it down real quick. I see. I see. Okay. So, before we get started, can I just like repeat like the algorithm
Go ahead.
so that I
Yep.
understand it? So the algorithm is saying that for consecutive same length, I mean same character, same characters of length 1, I would just append it to the string. But if it's has like more than one consecutive character, then I append it to the character with the length of that sequence, right?
That's right. Yes. And the
Sounds
string
great.
only contains lowercase English.
Mm-hmm. Yeah. Okay. Sounds great. Okay. This does seem like a straightforward question. What I can do, or what I'm planning on doing here, um is to go through this through the string one by one, one character by one character, and then for each character, for each character, I would just start counting how many of the same characters are in the sequence. And from that, I can just do like a condition checking. If it's more than one, then I would append the character with the length. But if it's just one, then I can just append the character. Does that sound like a logical approach to you?
Yeah, that makes sense.
Sounds great. Okay. Sounds good. Sounds good. Yeah, so with that said, I think I can just jump in to writing the functions. Uh, yeah, okay. So let's say I have an encode function that takes in a string like you mentioned.
Yep.
So that would take in input, for example. Okay, so we know that. So I'm just writing out some example questions that I would understand better as well. So if it's A, B, C, that would become just ABC, right? It just becomes the same string. And
That's right.
then
Yep.
AA, yeah, sounds good. And then AABC, that would become A2BC.
That's right. Yep.
That's great. Okay. Okay. So yeah, I'll just write down what I'm trying to do so that I don't forget. So what I'm trying to do is that for loop through the character, and for each character, I can just assume that it's the start of a consecutive subscription sequence. So assume that each the start of sequence. And then count how many same characters in that sequence. Characters, if I can spell. And then check if I should add length or not. Okay, sounds good. Okay. Yeah, I think we can start coding this up. Do you have any questions on what you want to clarify
No,
before
that
I
makes sense.
start? Or
No, that makes sense to me.
sounds good, sounds good. Okay, so yeah, I'll just do a simple loop to the string. Let's see. I'll just record the length of the string first. Yes, let's see. Okay, so I'm just looping through each character of the string right now. And for each character, I'm gonna assume that it's the start of the subsequence. So let's say I keep track of like the the character in question. So I would
Okay.
keep track of I would keep track of oh sorry target for example. I would keep track of the current character, and then say so then I would say as long as the current character that I'm checking is the same as the target, I can increase the length. So that would just mean oh, as long as the current character is the same as target, then I would increase the length, which I'm gonna have here. Um, yeah, I would increase the length right here. Yeah, to make this, okay, so I also need to keep checking the characters, right? So I would just increment. I would first check grab the current character, check with the target, and then increment the maybe I shouldn't increment it actually. Maybe I should not. Yeah, maybe I should increment in here. Yeah. Sorry. So yeah, sorry about that. Wait, let me gather my thoughts again. Yeah. So I would check for every characters after the current character. So okay, that would just increment as long as it's the correct one. I would just increment to the next one.
Okay.
Yeah. But here's like the caveat of this approach, because let's say I have um A, B, C, for example,
Yep.
the pointer would point to B. Yeah, the pointer would point to B before um the pointer would point to B, and then when I loop again, uh this I over here, the for loop increments would increase to C, and I would accidentally miss a B in there, and I shouldn't do that. And in addition as well, that I just found out is that I'm not doing like checking for I'm not doing checking for the bounds here as either. So if I keep increasing, I might go out of bounds. So it's a little bit careless on my part here.
Okay.
So is what I could do is I could check that there are actually characters after it. So I would just check that there are still at least n minus one. Oh, no, sorry. There are at least some characters after it, and I would just check it. I would just make sure that I is not n minus one yet, and then I would also check that the next character is equals to the target. Yeah, so I'm checking that the next character is equal to the target, and I'm checking for the bounds here as well. Okay,
Okay.
that makes sense. That makes sense. And if I'm correct, this should this should cover like the caveat that I just mentioned, because if the next character is not the same, it doesn't increase the index. And that's also checked for the bounds here. So yeah, so that should cover the caveat. And now all I need to do is that I just need to check if the length is well, let's say I have the encoded string for rest, for example, for result, and I first ask so for every scenario, I would just add the target character. So I would just first add the target, and then if the length is larger than 1, then I would also add the um, the length as well. That said, am I allowed to do this? I think I am. And then I would all I need to do is to return the result. And yeah, I think that should be it. So just to summarize this for loop real quick,
Yep.
is that I'm taking the current character, I make it the target, and then I would just loop through all the characters that are the same to the current target, and then I would add the target to start encoding it. And if the length is larger than 1, I would also add it as like part of the encoding algorithm. Does that look like it's a good
Yeah, that makes sense.
execution?
Yeah, that
Okay,
makes sense.
sounds great. Sounds great.
Let's talk about the time and space complexity of this method.
For sure. Um, the I'll just go from the outer loop to the inner loop. So for the time complexity, we are going through each character at most once. So this, because like since this inner loop is also increase the index. So if the loop keeps increasing the index, like the outer loop would not have the chance to check it again. So that's why the entire loop, the entire for loop, will check the entire for loop and the while loop. We check each character at most once. So because of that, we get an O of n time complexity. And yeah, so O of n. And then for the space complexity, we are creating a new string. We are creating a new string, and because okay, for the new string, it has the length of the new string is at most the length of the input. So because like if they are consecutive characters, it would reduce to only one character plus another character for this length, right? So the most characters in there would be the input, which is like every character
Yeah.
appears once, or every character appears at most twice. Yeah, so like if it's AA, the encoded string would be A2. So yeah, so like the space complexity for this would turn out to be O of n as well. And yeah, does that make sense?
Yep, that makes sense. What's the optimal?
That's great.
What's the best case space complexity?
Best case space complexity.
Yeah.
Best case. The best case space complexity.
Yeah, in other words, there exists an input
Yeah.
which minimizes space complexity, correct? Given that input,
Yeah,
what is the
that
space
makes sense.
complexity?
Give it like the best input, right?
Yes. What is the space? Well, best in terms
Yeah.
of space complexity, not necessarily anything else.
Yeah, okay. So my intuition is saying that if we get like all characters the same,
Okay.
it would reduce to only A2, A and the length of it. So the best case would be O of 1 because it was just the character and the number. Well, that's actually not true. That's actually not true
Okay.
because we could have infinite number of characters in here, right? So the best case in complexity would be
We can have n characters in there, by definition.
we could have n characters in there, and because like the length of the encoded will depend on the number of digits of the length of the number of digits of n as well.
And what
So
is
I
that?
guess, and if if I'm doing the math correctly,
Okay.
that would be log base 10 of n because of the number of the number of the num is it log base 10? Yeah, it should be log base 10. Like, it's the number of 10 of the number of the number of tens
Sure.
for because like for one digit to increase in the next one, it needs to be multiplied by 10 essentially.
And so therefore
So
the
it's
space complexity is
uh O of log n.
okay. Okay.
Yeah.
Let's put this aside and move to the next question because we got quite a bit of time.
That's good.
So let's start next question. This is going to be a binary tree question. Okay. So let me give you the definition of a tree node. Okay. So this is going to be a question. This is going to be a question where I ask you to write me a function. Okay. And in this function, you're going to take in the references to two binary trees, the roots to two binary trees. Okay.
Right.
And by the way, these are binary search trees. Okay, so not just binary. They're specifically binary search trees. Okay. And
I see.
And I want to return me a list of integers, and this is binary shape integers, right? Int val. Return me a list of integers that exist in both trees.
That exists in both trees.
Yes.
Ooh, okay. I see. A list of integers that exist in both trees. Oh, that's a really interesting problem. Okay. A list of integers that exist in both trees. There are a couple of approaches that I could go about this questions. Do you still see my mouse
I
here,
see them,
like
yeah.
in the main function?
Yep.
Okay, sounds good. So I'm thinking, like not the best approach, but the most obvious approach here that I could take is to traverse through both trees and then record like before that, like are the nodes, are the numbers within those trees unique, or are they guaranteed to be unique, or
What do you mean unique?
can they be, like, let's say if in my tree A,
Yeah.
I would have, can I have three and then its left node is its children node would be also like 3 and 3, or can it be um like 1, 2, 3?
Yeah, duplicates are allowed
Yeah,
in
that's
binary
1, 2, 3.
search trees. Yeah.
I see. And if in the case of duplicates,
It's always
do we sorry?
If it's a duplicate, we can assume it's always in the left subtree.
Sounds good. Always left. Always left. And do we I'm just verifying like the output here. So for the list of ints, do we care about like all like the correct number of duplicates? Like they have the same number of like threes and the same number of threes in the other tree as well? Or do I just return 3?
If both trees contain 2 3s, then you would need to return 2 3s. If the
If
first
both
tree contained 2 3s and the second tree only contained 1 3, then you should only have 1 3 in the output.
I see. Sounds good. Okay. 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 Sounds good. Yeah. Thanks for clarifications. Yeah, sorry. I was in the middle of something and I got sidetracked. So yeah, so like I was talking about the obvious approach that I could do here is that I traverse through both of the trees and record like the number of like what appears in each of those trees with a hash map, for example. So I would count the number of like threes in tree A, the number of threes in tree B, and then I would take not the difference, the minimum frequency of the two of them, and make sure that they both appear in both trees. So that could be my approach, but I'm trying to think if there's like a more clever approach, because after all, this is a PSD tree. So say for example, binary search tree. Are they guaranteed to be balanced or anything?
No.
No, okay. It's just binary search tree. Let's see.
That's right. Yeah, just binary
Hmm.
search trees.
Okay. Because I was thinking if my tree A has one, yeah, if I want to show you as well. So one, this gonna take a while, but okay, so if I have 1, 2, and 3, so that let's say it's a straight line down.
You can use a
Um,
drawing pad if it's easier. There's a drawing pad on the left. You can access.
oh really? Oh really? Oh
Yeah,
nice.
like
I
this.
didn't see that. Oh nice.
I'll clear it.
Okay,
Go ahead.
yeah, sounds good. It's also so hard to draw it on tablet though.
Yeah, it's not easy.
Okay. Okay, if I have 1, 2, and 3, and say, oh, on my tree, right, I have 2, 3, and 1. Am I guaranteed? Is there anything that I could guarantee in here? So let's say we both start out in the root.
Yep.
So 1 and 2. I'm gonna check the next. So I know that these two don't match. So these two don't match, but I cannot immediately say that 2 doesn't exist in tree A because 2 is larger than 1. Hmm.
Is there a particular traversal you can use?
Right, 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 right. Yeah, I could totally do a pre-order traversal to, because like for BST, the pre-order traversal is in order, right? So like if I have 1, 2, 3, 4, 5 in the tree, and no matter what shape it is, I would also get 1, 2, 3, 4, 5 back as the sequence of it. Oh, I see. That's actually a very good hint. Thanks. So, okay, I see.
Mm-hmm.
But if I were to do
A
pre-order,
pre-order. Do you
mhm,
remember the difference between do you remember the differences between them?
between pre-order and other traversal,
Yeah. Do you remember the differences?
yeah. So for pre-order, it's like left like the child. Oh shoot, you're right. It's not pre-order. Left node and then left node. Wait, sorry. I'm actually okay. It's left node, right node, and then root node. And then post order is wait, no, no, I'm actually yeah, I'm right. Sorry. Wait, I'm actually so tripping right now. Sorry, give me a second to gather my thoughts here.
You can
So
use the second tree as an
pre
example. Yeah.
yeah,
So what would
yeah,
pre-order
okay.
give you?
Yeah. So pre-order should be root and then left node and then like right subtree and left subtree and right subtree.
Yes.
And post order would be somewhat of the opposite. So it would be left subtree, right subtree, and then root. And yes, you're right. It's because we right, left, right. Because
Post order would be root, left subtree, children, then right subtree. So in this case, it would be the same, but yeah, that's not what you want either.
yeah, yeah, neither one. I wouldn't want neither one. You're right. So I would want what I actually want is in order.
Yes.
Yeah, that's why the name comes from. So that would be one. So that would be left subtree, root, and then right subtree. So that would give me the sequence of 1, 2, and 3. Yeah.
Yes.
Okay. Okay. I see. I see. Okay. I was being a bit too hasty there. Yeah. So let me double check on this tree as well. So it would be left left subtree. So I don't have any. So root, right subtree, and the right subtree. Okay. Yeah. So okay. Sounds good. So that would be 1, 2, 3 for both of them. Okay. I see. Um. So in that case, I would have to, okay. So in that case, the thing right now is like, how can I traverse? Do I do the same strategy to traverse both of them? And then and then store the vectors, that would defeat the purpose of like why are we doing this. Is there a way that I could, I'm just thinking a lot here, but I'm just
Yeah.
thinking like if there's a way I could like sync up the traversal and I could start traversing yeah, I could sync up the traversal with this. Um hmm. Yeah, how can I sync up the traversal for this? So I would go, so if I do a normal recursive type of traversal, I would first check the left one first, the middle, and the right one. So do I traversal when they are not the same? Hmm.
Well, maybe another question you can ask is, why do you want them to be synced up?
Why do I want to be synced up? Hmm. I want them to be synced up because I could eliminate, because I'm thinking of eliminating. Wait, you're right. Because I was trying to see if I could like do uh a branch pruning to see if like if for some reason like I'm at two and I know that one wouldn't be in the other tree, then instead of like checking the left subtree, I can just prune it completely and check the right subtree instead.
Yeah,
Just if that makes sense.
that makes sense. And what's your condition for
But
knowing
yeah,
that the other tree doesn't have anything less than 2?
if anything is less than two. So if I have, so let's say I have um four, eight. If the other one doesn't have anything less than two,
Yeah. In other
the
words,
other one doesn't have.
um,
Mm-hmm,
the reason you want to keep things synced up is because you want to know which way to iterate,
mm-hmm,
right? So you
yeah,
need to compare,
mm-hmm,
right? Like you need to compare, your first tree's current node versus the other tree's current node. And based on
mm-hmm.
what
Makes
condition
sense.
do you iterate?
When you say iterate, do you mean like
Yeah,
traversing?
traversing, yeah.
Okay. Conditions I iterate. Um, ah, right, I see. When they don't match is what I'm thinking here.
Yeah, they don't match. If it's greater, if you call left one A and the right one B, if A's root
Mm-hmm.
is bigger than B's root, what do you do?
If A root is bigger, right. Uh, I see. If A root is bigger than B root, then you would traverse down to the left side of A. That's yeah. If A root is bigger than B root, then you traverse that down to the left side of A. And does that sound correct? First
Yeah,
of
that's
all,
one way you can do it. Yeah.
okay. And if A root is less than B root, if A root, so if this is one, if A root is less than B root, do I traverse down B? I could traverse down B. Uh, yeah, I could traverse down B to keep tracking, to keep checking for B side.
Yeah.
Oh, I see. I see. Okay. Okay, I see. And if A equals B, if the root of A is equal to root of B, then I would just also traverse down to the left side of both sides. Yeah, of both sides. I would traverse down the left side of both sides because there could be duplicates. Does that sound
Yeah.
correct?
That sounds closer. Yes,
Okay.
that's right.
Okay. Sounds good. Um, my only problem. the reason why I feel like the reason why I had uh a lot of trouble trying to think of like how I can sync this up is because I was trying to do it with recursive, but I can't really, how do I explain this? Like I can't really do recursive on A and then pause it and then do recursive on B. Maybe. Like I don't think I could find a way to do that. So what I could do is that I could do a just a stack, like just a iterative approach
Yeah.
to iterative approach here using stacks. Does that sound more right on track here?
Yeah, you can. I mean, keep in mind that, yeah, like, yeah, you can use a stack for that. Stack to imitate a recursion stack because you're putting the parent onto the stack, and you're popping
Mm-hmm.
like, or not parent, but you're putting the current node on the stack. And if you're just
Mm-hmm.
repeatedly doing that, that's the same thing as recursion, right?
Right.
But yeah, like you
Yeah.
could do it that way.
Okay.
Yeah, it would be okay.
Okay. Okay. Sounds good. But then again, if if I were to do it with stacks, I would have to also I would also have to like have another headache of uh I would have another headache of like if I visited node if I already visited a node or not, because I would have to push the root back to stack and then push the left node on top of it and so on. So maybe maybe sorry, let me take it back. Maybe I'll stick with recursion for now, and then we can see how it goes.
Okay, sure.
Sorry about that.
Yeah,
Yeah.
sure.
Okay. Okay. I'll just do define functions real quick. So we want to return a list of integers, right? So let's say we have like general functions that returns a vector. Oh shoot. Okay. Okay. So we should return a vector. So this would be find common, for example. And so I would get a tree node root A and tree node root B. Okay. Okay, what can I do here? So like we mentioned, if they both not equal, I mean, sorry, if if A is less than if A is less than B, then B traverses down to the left side of it. If A is larger than B,
Mm-hmm.
wait, no, yeah, if A is larger than B, then if A is larger than B, then A traverses down to the left side of it. The left side of it, and if they are both equal, you also traverse down to the left side. But then what about the right side?
I
It
think
could also
I think this
mhm,
is. I think you're getting a bit confused about the mechanics of a tree. Um, the like we discussed, right? The in order traversal of
mhm,
a binary search tree gives you the elements in non-decreasing order,
yeah,
right?
mhm,
So
mhm,
so you have A and B,
right,
and you're traversing them. You have a way to traverse both in non-decreasing order.
mhm.
So there's no left or right. It's just next.
I see. Sorry, but in this case, I still haven't found a way to like prune the tree either, right? Like I don't see a way to like cut a certain branch off. Because like if A is not equal to B, like there's nothing like decisive to tell me that you can't cut a branch off. Wait, let me think about it. Because
That is technically true. In the in order traversal by default does not have pruning, right? I
right,
recommend you don't try to prune anything, and you just do the naive in
hmm
order traversal.
Right, I see. But okay, but in that case, if we're not pruning anything, like instead of me trying to figure out or like trying to remember how to do the traversing, I could also do like the normal like the obvious approach of traversing only one tree first and then traverse the other tree and check both of them, right?
You could do that, yeah. You could do that. I mean,
Okay,
yeah, you can start with that. Yeah.
okay, okay, sounds good. Okay, back to square one then. Sorry about that. So okay, so okay, if we just go with like the naive and approach um uh the naive and obvious approach, then we can just do like I can do any kind of traversal for that. Like I could do either if a search, pre-order, post-order, or well yeah, or just a level order as well. So let's keep it simple, and I wanna use yeah I wanna do I wanna do a level order traversal instead. Um, which is what sorry, level order. Yeah, level order traversal.
Okay.
Because I use a queue, and yeah, yeah. So yeah, so sorry. So what I can do is that let's say I have a uh count counts nodes, for example.
Mm-hmm.
I have a function called count nodes, and I would take in a tree node, um, and a reference to and a reference to a the counter, which is like hash map, for example. So let's say I have a hash map that maps from the value from one value to the frequency. So I would call this frequency, for example, and I would have a reference to it. What I could do is that I can create a the hash map here. I'll call it frequency as well, and then I can pass both nodes or like one node at a time to the functions and
Mm-hmm.
count the frequency and then take the difference between the two of them. So what I could do is I could either create a new hash map or I could be yeah I could why not create a new hash map? Doesn't make that much of a difference. So I could do count nodes for root 8 A, for example, and then frequency A. And then I would also do the same thing for root B and then frequency B. So frequency A and frequency B now would contain the result of um, yeah. Frequency A and frequency B would now contain the result of like the frequency of each value of
Okay.
each unique value in each node in each tree. Then what I can do from there is that I could iterate through one of the counter to one of the hash map.
Mm-hmm.
I see pair, for example, and then I would check if the value is in the yeah I would check if the values is in the auto map and which one if it is then what is like the most common if there is like if there is like how many duplicates do they share? Does that make sense so
Yeah,
far?
that makes sense.
Yeah. Sorry, I'm just trying to speed through
Yeah.
to make up for the time that we lost. So all I need to do right now is that so I would check if B has whatever A's has. So it if it's less than or equal to you know yeah I could also do this. Oh, no, I shouldn't do that. Okay, so if B I would check if B has the value of A um so it's less than or equal to the end of it. So if it does, then I can push back the number of duplicates that they share, and the number of duplicates would be the minimum between the two frequency.
Yep.
So that would be p dot second as well as frequency b of b dot first. So yeah, so I would just push back. Sorry, this is not going great. So I would also check. I shouldn't be pushing back the frequency. I should be pushing back the value itself, the number of value itself. I
Yep.
see. So I would do a um I would do like a let's call it let's call it nums for example, and that would be the minimum, the frequency.
Okay.
And I would call num frequency for example, and I would check as long as there are some duplicates left, I can just push the value into the result array. So I could do that by do p dot first. Yeah, and this should fill up the right number of duplicates.
You need to decrement num frequency, right?
There you go. Yeah.
Okay.
So yeah, it would give us the right number of duplicates. And do you want me to code this one now as well,
That's fine.
or
We can skip that. And for this
okay.
function, you return res at the end, right? Okay. Let's go through the time and space for this problem.
Mm-hmm. Yeah, definitely. The time complexity here, most of them would take around these. Oh, sorry, am I okay? Most of them would just take around these two function calls. Well, that's not quite true yet. But the count nodes, since it's going through all the nodes in A, and the count nodes also goes all through all the nodes in B, the overall time complexity of these two steps here would be the maximum time that to go through A or B. So let's say if we denote small a as like the number of nodes in root A, and small b in the number of nodes in root B, we would have the time complexity here as max of A and B, for example. Does that make sense so far?
Yep, that makes sense. And
Sounds good.
like are we assuming in this case that it takes linear time to traverse the tree?
Yeah.
Okay.
Yeah. We going each node only once.
Okay.
And yeah, and so for this, it's basically the same as well, because since we're going through like the frequency of each node, of each unique value, it's essentially going through the same number of nodes again. So that would just be that should have the same complexity as these two functions here. So what we would have is a maximum of A and B as well.
Yep.
Yeah, so like the overall time complexity would be the maximum number of nodes in either tree. And for the space complexity, since we're storing unique values, and a tree can incidentally have only unique values, we could like store up to the number of nodes. And since we have two different trees here, it would also be the same. Like the space complexity here would be the maximum of the number of nodes in root A or the number of nodes in root B as well. Yeah, for space. And yeah.
And well, it would be in this case. We could be more precise. Say the space would be A plus B.
Oh shoot. Yeah, you're right.
That would be true for both time and space.
Mm-hmm.
But yeah, technically, O of max is still technically correct.
I see.
Yeah. Okay. Yeah. That makes sense. Let's stop here. Because there's a lot to talk about in this one, right? This is probably a more interesting question I haven't seen. I kind of have to start this off by just asking you. By the way, right? There's two questions here, right? The second question was about basically finding the common value between two trees, and the first one was about the encode question. Encode, I don't think there's much to talk about. I think you solved it basically optimally, so I don't think there's anything to say there. Let's focus the time on the second question. Is there anything about the first one
Sure.
you wanted to talk about before we moved on, or can we just move on?
No.
Okay, then yeah. So how do you feel about the second one?
The second one's, I feel like the intuition is definitely very obvious here. I could definitely code this up and like this one up like in like really really fast.
Mm-hmm.
But yeah, it's either so that's why I kind of got. It's not that I got cocky about it, but I feel like I could have done a little bit better, and I
Yeah.
feel like it would be more interesting for me to start thinking about the optimal way instead.
Yeah.
But I'm not sure if that's the correct approach here because I feel like I kind of led the interviewer like you around a little bit, and it's a little bit confusing.
Okay. Yeah. I mean, the main thing about the question here was that there was some confusion at the beginning about how you wanted to proceed, right? And so, I mean, okay.
Yeah.
First of all, by the way, you got to know the order traversals, right? Like pre-order, post-order,
Yeah.
end order. Like level order is basically
Yeah.
overused, to be honest. But like pre-order, post-order, and end order, you have to know them. Like there's no excuse, right? Like you have to know them. So
Yeah, that's true.
right, this one, like if you use pre-order traversal for this one, it would just be incorrect. Like it just wouldn't work, right? There's no way to make pre-order traversal useful in this problem, really. Okay.
Yeah, definitely.
So in-order traversal, right? Remember, like the in-order traversal, as you pointed out, right? It traverses the binary search trees in order, in increasing or in non-decreasing order, right? That's the purpose of the in-order traversal, right?
I see.
Right, and
Yeah.
so the purpose here is that you had a strong intuition for traversing the two trees together. Okay, why is that? Because this question, when I say this, right, if you traverse two binary search trees in order, this question is merge linked lists. Have you solved that question before?
Yeah, I remember.
Right?
Yeah,
A binary search tree. If you traverse a binary search tree in order, that's a sorted linked list.
Oh, that's why you hinted there's only next and not left and right. I see.
Yes, because well, if you do, I mean, if you think about in general about traversals, there's only a next. Like there's no traverse left traverse right. It's just next, right? That's what traversal means in this context. And so yeah, if you do an in-order traversal on a binary search tree, it becomes a linked list. Do you see what I mean? And so this question essentially becomes find the common elements in two sorted linked lists. And I think if that was a question given to you, you would solve it much quicker.
Right.
Because
I see.
all the same stuff would apply, right? Now the intuition here for how do we actually so there's now okay, so from here there's two things I want to talk about. They're separate. Okay. The first thing is I'll get this out of the way because it's a bit controversial. Okay. C++ is definitely not. It's definitely got some sussy stuff going on here. Okay. Two notes. First of all, this took you about 5 minutes to write. Okay. In Python, this is 2 lines. In Python, it looks like this. There, that's Python. You intersect 2 dictionaries. That's what it looks like. Okay. So C++ here is definitely holding you back a little bit. I know you were doing you. I know that you were a bit nervous, a bit of a time crunch, but keep in mind that if you find yourself solving questions that you're struggling with the mechanics of, that's a sign that it's worth more and more investing in a language which can solve that more quickly, right? Because
I see.
In a time crunch situation, you don't want to be you don't want to be writing this, right? Like this is error prone, and stuff is going on. Okay, so that's one thing to keep in mind. Okay, the second thing I want to keep in mind is I don't. By the way, I don't actually know how familiar you are with C++. Do you is C++ your primary language, or do you use a different language for your projects or coursework or what?
I use C++, basically my primary, like for Leetcode.
Do you know about generators?
Generators? No, I do not actually.
So let me show you something. Okay, so look at the tree node struct right now. Okay, Now I'm gonna, so of course I'll save this code for you later so you can copy it, but
Mhm.
okay, hold on. Let me explain what's going on here. This
Yeah.
solution is not optimal. The reason it's not optimal is because you are using a plus b space, and it's possible to do this
Right.
question in log a plus log b space. In other words, you don't need extra memory except for the traversal itself. And the
Mhm.
reason that's the case is because remember, right? If you're marching two linked lists side by side, why do you need more memory? You don't. So the only
Yeah.
memory
Makes
needed
sense.
is to traverse the tree to make it a linked list. Okay.
I see.
The difference between traversing the the difference between traversing the nodes and then traversing the tree and collecting the node frequencies. The downside there is that you have to store all of the frequencies, right? This is where your space complexity comes from.
Mhm.
If instead of that
Makes sense.
you were able to generate the next in order element in a tree, you wouldn't need to count the frequencies. And so now, I want to just be clear. I'm not a C++ writer, but what I can say
Yeah.
is that a generator will look something like. Let me think. I think it's called generator int. So you generate int, and then the function is called in order. Right. Like the by the way, so like this is inside the link of here. So I recommend you study that. Okay. And
Right.
this is very so this will be what if left if left, oh right, yeah, and then so you know what, I'll copy this because I don't actually need to invent the wheel here. The different, okay, why is this important? This is important because this basically gives you elements on demand. Oh, it's supposed to be like this.
Oh.
This gives you elements on demand, and the reason that's significant is because if you have if you have a reference to an instance of a generator for a tree, you wouldn't need to traverse the entire tree at once. You would only need to traverse it on demand.
Right.
Right.
That makes
And
sense.
so what that lets you do is this question literally becomes merge two sorted linked lists or find common elements in two sorted linked list. Right? Like let me just do
Right.
let me just do a bit of pseudocode here, right? Like just for the sake of argument, just for
Mhm.
void f tree node A. I'll copy your code here. Right. So you'd say I don't know what's called auto. Generator A equals a what is it called? Traverse in order, right? How do I resist this?
I see.
Right, and then you would just say, okay, so so right, so generator. Oh, I need semicolons. I haven't written C++ in like years.
Mhm.
I think it's next or whatever. It doesn't really matter. Right, like
Yeah.
you would get
Makes sense.
right, like you would just get two heads, right? So you would say so, right? So auto
Yeah.
cur A, right? Cur A, cur B,
Mhm.
right?
Mhm.
Whoops.
Makes sense. Yeah.
Right. I'm trying to just demonstrate the point here.
Yeah.
Right? And then now you say, okay, so for example, right? So check if equal blah blah. I don't care about that, right? So then say if cur A is less than cur B, right? Then we do cur A equals cur A dot next, right?
I see.
And
I see.
else do the other way around, right?
I see.
Stuff, right? Whatever. And then the point here is that you check if equal. If they're not equal, you just increment the one that's lower. And you check if they're
That makes
equal,
sense.
and vice versa, right? And the
Okay, that
benefit
makes
here
sense.
is that this right here, right? We're not actually using any extra memory here. Right, so all we're doing is we're just requiring that we have a pointer towards the next one, and so the maximum memory here is just the memory used to iterate. It's just the memory used to iterate through the tree, which is the height of the tree, right? Like that's the maximum call stack, which is log A or log A plus log B.
I see.
Right.
I see. Okay. That makes a lot of sense.
Yeah, and then I'm not doing all the housekeeping here, but I mean I'm not counting the result as part of the memory complexity because that's just required output. But That's kind of how it is. Okay,
Okay, makes sense.
that's the main piece here. I think you missed, but the solution you came up would still work. It just wouldn't be optimal. And I think as long as
I
you
see.
recognize, like for example, if you did that and then you recognize that it wasn't optimal, I think that would still be like a relatively strong performance. But I think the learning, the main learning here for you is that you need to recognize when a specific approach isn't going to pan out, and that you should default to something easier, right? Because for
I
example,
see.
had you just written this easier naive solution first, you would have had time to also implement your like your traversal almost certainly, right? And
I
that
see.
would look more complete in that sense.
I see. So I see. That makes sense. So so I guess this kind of circles back to like my question at the start. Like so like how do you think my approach there was like because I was like I know that my approach wasn't optimal. I know that there's something that I'm missing.
Yeah.
So I tried to like play around and try to experiment a little bit. So
Okay.
was that the right approach? Like should I have done that or should I have just like okay, I'm just gonna write out the naive approach right now and then I can come back and optimize it later.
Good question. That depends on two things. The two things that depends on is how confident you are in your ability to find a more optimal solution, and
Mm,
how what your estimate for how long it would take you to write the naive implementation, right? For example,
I
in
see.
this case, if you think it only takes you 10 minutes to write the naive implementation and you haven't thought of like a good optimization, or you're not confident in it, then I would say
Mm,
write the naive solution, and while you're writing it, spend that time thinking about, if you can, spend the time thinking about how you can optimize it. Okay,
I
because that's
see.
like an insurance
I see.
policy, right? In most cases, I'd say it's only worth going straight to the optimal answer if you have there of two things. If first of all, if you can bail easily, right? So if you can bail easily if it's not that different from another solution, then it's okay to risk it.
Mm,
Or
right.
if you know that it's too big of a discrepancy between the optimal one and the naive one,
I
right?
see.
Like for example, if it's a relatively if it's a company that you're trying to interview for, and
Mm,
it's a company with relatively difficult interviews, right? Like they're asking difficult problems. You get
mm,
0 points. I'll be honest, like you get 0 points to write a naive answer because that's not the point. Like that's not the skill, right? In that
I see.
case, it's worth it to risk it. Like you should have a higher risk tolerance threshold to try to get the optimal
Mm,
answer, because writing the naive one perfectly will not pass you. Like you will not pass.
I see. I see.
So that is a bit of a
Okay.
judgment call, but you should have that call going into the interview. Then decide on the spot
Mm,
is it worth risking, right? So
I see. I see. Okay. That makes sense. And okay, sounds good. And sorry, just like one quick question about this as well. For the generator part here,
yeah,
that would require me that would require me changing the structure of the tree node, right?
yeah, it would.
If
Yeah.
if I wasn't allowed to do that, like I'm sure that there's still a way to do this pretty it's not too bad, right? Like there
Um,
should be a way to do
well,
this.
I see. So here's why I can't really help you. I don't really know C++. In languages
Right.
I know, like Python, JavaScript, Java, you can write your
Mm-hmm.
custom iterator, which is essentially a generator. So in
Oh,
those languages, it's trivial. You can just pass it a route, and you
mm-hmm.
can just call next on it. Like if you think about it, right?
Oh, I see.
If I gave you a question, this is not related. If I gave you a question, okay,
Mm-hmm.
uh,
Mm-hmm.
make a class, okay, construct cons, uh, take a tree root, okay, implement
Mm-hmm.
next, give next in order element, has
Oh,
next, return true if only blah, right? This is what you're implementing,
mm-hmm.
right? Like if you had to implement this, this would be relatively trivial. So I don't know in C++
Yeah,
how it works, but I'm sure it's possible somewhere.
I see. I see. I see. Sounds good. Well, thank you so much.
For sure.
That makes a lot of
Yeah.
sense. Yeah.
Yeah. By the way, in the sample, this is a sample problem on Leetcode somewhere. Some of the problems, some of the solutions, I don't know. I like this question is so obviously a generator problem to me. I'm sure you can find a solution on there that uses a generator. I don't know if it's in C++, to be honest, but I'm sure you can find at
Mm-hmm.
least a Java or a Python solution that uses generator, or they call it iterators there too. So
I
you can
see.
try
I
to
see.
find a sample solution there to compare.
I see. Sounds good. That makes sense.
Cool.
That's great. Thank you so much.
No worries. Yeah, I mean, good showing today. I think overall, I mean, remember, right, there were 2 problems you did today, right? So I think
Hmm.
it was overall pretty strong showing. But yeah, it's a bit of a technique thing on the second question. Technique. Yeah.
Sounds great.
Great.
Sounds great.
Thanks for your time.
That's great. Thank you so much. And are you coming tomorrow for the meetup?
Tomorrow is yeah. I'm planning to come tomorrow, but I don't know exactly
Oh,
what
nice.
time I'll be there. What time is it again?
Okay.
Is it 2 p.m.?
Yeah, it's at 2.
Yeah, I'll try to be there somewhere around 2 to 4, right? Yeah, I'll probably stay a bit longer, depending how it is.
Sounds great. Sounds
Are you
great.
coming?
Right. Yeah, yeah.
All right.
I do want to meet. I do want to meet you in person.
All right. Well, come by and say hi.
But yeah,
Yeah, come by and say hi.
yeah, for sure, for sure, for sure. All right.
Take
I'll
care.
talk to you
Take care.
later.
Bye bye.
Thank you so much. Bye bye.
I saw one question, not question, comment I guess in the chat from Matthew. Sorry, I didn't have the chat up. I was focused on this C++ thing. An iterator call next node could be useful for traversal. Exactly, right? Matthew, wait, you were using what were you doing? You were doing Java? Yeah, in Java this would be like a custom iterator, right? Like if you overwrite the iterator class, if you implement the next has next and next, right? That's essentially what the generators are, right? In essentially like a generator in this context just means lazy loading the next element of a traversal. And so you can have a generator for anything really. Like for example, you can have a lazy load for this tree traversal. You can have it for going through a list if you want, right? Like generally speaking, the original iterator was for collections, the Java collections, right? In this case, it's actually particularly useful because you don't want to store all of the like you don't want to store all of the state of the tree in memory. Like that's the point of the optimization, right? And so if you can let this generator or this whatever class you might have handle the logic of traversing, and you just care about the next element in order, then yeah, it's much easier. But yeah, pretty interesting problem. Pretty yeah. Like I think most of the time, if you can think of just a way to do, if you like, the key is like, okay, in order traversal, that's the first key, and the second key is can you come up with like a reasonable way to join the lists, and the optimal solution using this is a bit more nuanced, and I've only had one person who I was able to lead to actually use this before. That was Python, by the way, and that person knew generators, so it's a bit different, but yeah, it's a good problem overall. I think the iterator part for well, I don't know, like at least in my school, the like in order traversal was taught in like second year, and it's actually very easy if you think about it, right? Like if you like in order traversal is just left, root, right, like that's it, and the generator part slash iterator part is just do you know your language well enough, right? Because as far as I know, every language has, or every language that's worth using has a way to implement lazy loading traversals. But anyways, yeah, that sort of is the key of the problem, and that's how you save substantial memory. Can't believe for different ways to traverse. Yeah, I mean, once in a while, sometimes people get caught up too much in the sauce, and they forget the basics, right? So this is a reminder to everyone out there to just go review all the ways to traverse. Right, pre-order, post-order, and order. Those are the 3 main ones. Level order is kind of useless, but like is sort of a thing, right? Level, well, I was being a bit facetious. Level order can be useful sometimes when you're modeling a problem as sort of like a is what they call like a BFS, right? Like a BFS is level order traversal, right? And so, for example, if a node is a state of the problem, and you're just trying to figure out how to go from state to state, right? Then level order makes sense, in that context. But that's typically for graphs and not for trees. But yeah, technically, yeah, level order traversal. All right, guys, I'm in the stream. Everyone go home. Where's my OBS?